Hello and welcome back to Gaffy's Grinds. My name is Mr. Gaffy and I'm here trying to help you guys understand some difficult concepts in junior cycle science. In these videos, we will take some difficult concepts, I will break them down, try and help you understand them, and then we will do some practice questions on those topics. Okay, just some general tips on using these videos. It's really important that you turn off your phone or put it into a different room. Maybe leave it in the same room that your parents are in. And this is really important so that you don't get distracted when you're watching the video. Also, if you have other tabs open on your tablet or computer, you need to close them now. Okay, and again, this is so you don't get any notifications that take your attention away from the video. And the very last thing, but the most important thing, is that I'm going to give you some tasks and some questions to do. It's so important that you do those tasks and not just watch the video and listen. You must be doing the tasks, otherwise you're not going to learn anything. So it's really important that you do the questions, do the tasks. Okay, so I'm just going to open up my whiteboard here. Okay, in the last lesson, we learned about making a type of a mixture. So we had the example, we take our beaker, which is a glass that we keep liquids in the science lab. So we take our beaker and we fill it up with some water. So this is liquid water. Okay, we then took a solid substance and it was called sodium chloride or salt. And we took our salt and we put it into the water, into the beaker of water. We then, at the end, when we were all done, we finished with basically the salt looked like it disappeared and it looked like water again, but this was what we call salty water. I told you what the name for this process is, this arrow here. I told you what this process was called when we take salt, we mix it with water and make salty water. What I want you to do now is I want you to say out the name of that process loudly. If you said dissolving, then you are correct. Well done. This process is called dissolving. Taking salt or a substance like salt, put it into water, mixing it so it looks like it disappears, and then you end up with salty water. There were some other words that we learned, okay. One of those words was solute, S-O-L-U-T-E, solute. I want you to tell me now, out loud, I want you to say which one of these substances, either the liquid water, the salt, or the salty water, which one of these substances is the solute? Say it now. If you said salt, then you are correct. Well done. This is the solute. We call this a solute. Why is it the solute? Well, this is the substance that dissolves. Substance that dissolves. And the substance that dissolves we call the solute. I want you to tell me now which one of these substances that are left, either the liquid water or the salty water, which one of these things is called the solvent? Say it out now. If you said the liquid water, well done. The liquid water is the solvent in this example. Why is it the solvent? Well, it's the substance that does the dissolving. That does the dissolving. And the substance that does the dissolving, we always call the solvent. It's usually a liquid. In this case, it is a liquid. Sometimes the solvent, though, might not be a liquid. The solute is usually a solid. An example, in this case, the salt is the solute. But we have other types of solutes too. An example of a different type of solute would be a gas solute called oxygen. Oxygen is a gas that we breathe, but fish, for example, also need to breathe oxygen. So oxygen needs to be able to dissolve into water so that fish can breathe it through their gills. So if there was no oxygen dissolved in the water, then the fish would all die. Okay, so it's really important that gases can also dissolve. Okay, the last substance we have left here is the salty water. If you think, what I want you to do is I want you to now say the name of that. It's going to be similar or something like solvent and solute. So very quickly, I just want you to say out loud, what do we call the salty water in this example? If you said the solution, then well done. That is correct. So what is a solution? A solution is the solvent and solute after dissolving. Solute and solvent after the dissolving happens. Okay, well done. Now, I asked you to explain this in terms of particles. So the solute in this case is the salt, and it's a solid. That means we know it's made of particles that are arranged in rows like this. Excuse me. Okay, so we have, oh, I'm making a mess of this now. Excuse me while I start this again. So I have solute particles. I have 9 of them. That's how I draw a solid, because salt is a solid. 9 particles all touching in nice neat rows. Now, something is holding these particles together. If you know the answer to this, I want you to say it out loud now. If you said strong forces of attraction, that is correct. Well done. Strong forces of attraction, that is correct. Now, what happens when we dissolve is that these strong forces of attraction get broken, and then the particles can separate and mix with the solvent. Okay, so strong forces of attraction, and they get broken when something dissolves. When a solute dissolves. Okay, so this is called dissolving, when the strong forces of attraction in the solute get broken, the particles can then separate and mix up with the solvent. Dissolving, should be dissolving, sorry. Okay, now in our very last example, our question that we did, it was question 84 in the booklet. We had the example of sand. So if we take our beaker of water again, okay, and this time, instead of salt, we're going to add a different solid. We're going to add sand. Now I'm going to draw these particles as yellow, but it's still a solid, so it's got 9 particles, all touching, arranged in rows. And we took our sand and we put it into the water. And this is what we got at the end. So we had our beaker, our water was still there, but this time the particles did not break up. Okay, the particles did not break up. So the sand particles were still arranged in rows, still stuck together. So this, we say, sand did dissolving happen? No, sand did not dissolve in water. Another example, if I might just add, is if we take the example of a hand, and this is going to be a really bad hand. I'm not very good at drawing hands, but you'll still get the idea. There's 4 fingers and a thumb, and on that hand we've got some lovely, pretty red nail polish. Now we know that if we take some water and wash our hands, and we're doing a lot of washing our hands, COVID-19 procedures, if I ask you, did dissolving happen? Hopefully not, because if your nail varnish dissolves when you wash your hands, then it's not very good nail varnish. Okay, so nail varnish, we say, does not dissolve when we put it in water. Well, does that mean it's going to be there forever? Well, of course, that it's not going to be there forever. Nail varnish is not permanent, and the key thing is, if you want to get rid of it, you don't use water. You're going to have to find another liquid which can act as a solvent. Okay, so the liquid we're going to use is called nail varnish remover. And the chemical in nail varnish remover that's able to dissolve the nail polish is called acetone. A-C-E-T-O-N-E, acetone. So you should say that now after me, A-C-E-T-O-N-E, acetone. Okay, and when we do that, when we put acetone on our nail polish, it does dissolve. It does dissolve. So you see here, we've got the same substance, nail polish, it's the solute, but we've got two liquids that we're trying to use as solvents. So we say that the nail polish does not dissolve in water. So the solvent, when it's water, it does not dissolve. But for another solvent, nail polish remover, it does dissolve. So we've got two new words now we're going to talk about. The first one is the word soluble. Now, if we think about where that comes from, solu refers to dissolving. Anything which is solu or anything that sounds like that is like solute, solution, S-O-L-U, so it's to do with dissolving. Bull comes from the word able. Okay, so something which is soluble is able to dissolve in a solvent. Okay, if we take the same word, soluble, and we put the word in front of it, we now have able, dissolve, and in this case, in means like incapable or not able. So something is insoluble if it's not able to dissolve in a particular solvent. Okay, now it's very important that we clarify whether what solvent we're talking about. So if we were to write some sentences using these words now, we would say nail polish is insoluble. Now I can't just leave it insoluble because we know it does dissolve when we get the right solvent. When we get nail varnish remover, it does dissolve. So we have to say what it is insoluble in. Nail polish is insoluble in water, but it is soluble in acetone. Okay, so nail polish is insoluble in water, but it is soluble in acetone. All right, so it's time to do some practice now. So we're going to do some practice questions. Okay, these are the practice questions. Okay, so we've got questions 85 to 90. Why is it not 1, 2, 3, 4, and 5? Well, these questions come from the booklet that my class uses to learn about particles. So these are the numbers of the questions from the book. But we do our questions in our practice copy, guys. So I need you to get your practice copy and I need you to pause the video and try to do questions 85 to 90 now for me. Okay, so pause the video now. Okay, welcome back. And you should only be watching the video if you have tried to do all of the questions 85 to 90. So I'm going to show the answers now in a minute. And like I said, there's absolutely no point in just watching the video and not trying the questions. You're not going to learn anything. So make sure you try the questions. I'm going to show the answers now. Okay, these are the answers. Okay. So if you didn't get any of those correct now, it's important that you make your corrections to your answers. Okay, we're just going to do one last little bit for today. Okay, in this video, we're going to take a look at comparing two solutes. So let's say, for example, we have a beaker of water. And in the beaker of water, we have, I'm going to measure the water this time. I'm going to say there is 100 milliliters of water. So 100 milliliters of water. Now, into there, I am going to put some sodium chloride, salt. So I've got water and I've got salt. And I'm going to put the salt in. And I'm going to keep putting salt in. I'm going to measure up the amount of salt and I'm going to keep putting salt in and see how much I can get to dissolve before it stops dissolving. Okay. Now it turns out that when I do this, I can fit 36 grams of salt. I can get 36 grams of salt to dissolve in 100 milliliters of water. Okay. Now, I have a second solute. I'm going to take a beaker and I'm going to use the exact same amount of water so that it's fair. It's a fair comparison. 100 mils of water again. Okay, and that was water too. And just over here, I should probably write 36 grams under the salt, because it's 36 grams of salt that can dissolve. I'm going to take a different substance. I'm going to take a pile of, instead of salt, I'm going to use sugar. I'm going to take the sugar and I'm going to put it in the water and I'm going to mix it. I'm going to see how much sugar I can put in before it stops dissolving. And the answer is I can fit 90 grams of sugar in. Okay. Now, hopefully you can see that we have the same amount of water here. So it's a fair test. It's a fair comparison. And you can see that clearly I can fit more sugar. I can dissolve more sugar in the same amount of water than I can salt. I can dissolve 90 grams. The salt, I can only dissolve 36 grams. Okay. So we have a word to describe this. Okay. We use the word solubility. Okay, so it's very similar to the other word, solubility. Okay, so where does the word come from? Solu means dissolve. And ability comes from the word ability. It has the, how much ability does it have to dissolve, basically? How much ability does it have to dissolve? And it's got to do with the amount that you can dissolve in 100 mils of water. So we say that sugar has a higher solubility than salt. Sugar has a higher solubility of salt, and this is because I can dissolve 80 grams of sugar in 100 mils of water. I can only dissolve 36 grams of salt. Both of them are soluble. You can dissolve both of them, but one you can dissolve more than you can of the other. Okay, so we're going to stop now and we're going to do some more practice questions. Okay, so this is the practice question. Okay, question 97. It's question 97 in your booklet as well. Okay, if you're not able to answer any of these, it's a good idea to pause this and go back and watch the video again. The answer will be in there. Okay, so question 97 says there are two solutes A and B. I can dissolve 15 grams of A in 100 mils of water and 20 grams of B in 100 mils of water. So now you have 4 little questions to practice there in your practice copy. So I want to pause the video and try to do these questions now. You should only play the video again when you have tried all of these questions. Okay, welcome back. You should only be playing this video now if you have tried all the questions, parts A, B, C, and D. You must try and answer it in some way. Even if it's wrong, that doesn't matter. We can fix it afterwards, but you must at least try. Okay, so try to do it. Go back and watch the video if you're not sure of the answer. Okay, so I'm going to show you the answers now. There they are. Okay, so B has a higher solubility because you can dissolve more of it, 20 grams in 100 mils instead of 15 grams of 100 mils. The next question said if I had 200 centimeters cubed of water or 200 mils of water, hopefully you can see that that is twice the amount of water, 200 mils. So how much of A could I dissolve? Well, if you've got twice the amount of water, you can dissolve twice the amount of salt. So that's 2 times 15, which is 30 grams. If I add 20 grams of A to 100 centimeters cubed of water, how much will be left over? Well, we know that 15 grams is going to dissolve, so that must mean that the other 5 does not, so there'll be 5 grams left over. And 12 grams of C, so it's a new substance, 12 grams of C can dissolve in 50 centimeters cubed of water. Compared to A and B, how soluble is it? Well, if 12 grams can dissolve in 50 cm cubed, then that means 24 grams can dissolve in 100 mils. Okay, so 100 mils. So if 12 grams can dissolve in 50 mils, that means twice that amount. 24 grams can dissolve in 100 mils. So that lets us compare. It is more soluble than A or B because in 100 mils, 24 grams could dissolve. So that's more than A or B. All right, well done if you've got all the answers right today. You've done really well, and I'll see you in the next video.